Today we're going to look at parallel and perpendicular lines. So a refresher, to be parallel, that means that your lines are going to have the exact same slope. And if they have the exact same slope, your lines will never cross one another. They'll never intersect. So here we're asking ourselves, are these two lines parallel? Well, in order to see or test, you look at their slopes. If they have identical slopes, which in this case they do, then yes, they're parallel. So yes, these are parallel because they both have slope of 3. How about these two lines? Okay, the one on the right has a slope of -4/3. However, this one is not as easy to tell what the slope is. So we need to solve for y. So I subtract 4x and divide by 3. That leaves me with y equals -4/3 x plus 2. Since they both have a -4/3 slope, then yes, they are parallel. Okay, we're going to be asked to write a lot of equations that are parallel to a particular line. So in this example, we're supposed to write an equation in slope-intercept form that goes through the point -1, 1 and is parallel to y equals 2x minus 1. So first thing is we need to find our slope, and since it's parallel, we know our slope will match this equation. So we know our slope's going to be 2, and then they give us the point, so we plug -1, 1 into our equation. Minus a negative turns into plus, so y minus 1 equals 2 times x plus 1. Distribute on the right side. Now we're going to add 1 to both sides. We get y equals 2x plus 3 is our equation that's parallel to 2x minus 1. Okay, when we talk about parallel lines, we also frequently talk about perpendicular lines. And to be perpendicular, that means that your two lines cross at a right angle or a 90-degree angle. Earlier with parallel lines, we said our slopes were equivalent. In order to be perpendicular, your slopes have to be opposite reciprocals. So we're going to look at what that means. Reciprocal means flip your fraction, and then opposite means change your sign. So here we have 3/4. The opposite reciprocal would be -4/3. We flip that numerator and denominator and then make it the opposite sign, so negative in this case. Here we have -2. Well, you can imagine that that's really a -2/1. So when we go to flip that fraction, it becomes -1/2, and then the opposite, we change that negative to a positive. And then 1/7, the opposite reciprocal would be -7/1, but we always write that as -7. So let's write, let's decide if a couple lines are perpendicular. Here we have -1/3 x plus 7 and 3x minus 1. We want to know, are they perpendicular? Again, we're only looking at their slopes. So we have -1/3 and +3. You can think of that as a 3/1. Therefore, they are opposite reciprocals. Okay, here we're wondering if these slopes are perpendicular. So we are just given 4 points. These first 2 points create one line, and the second 2 points create a second line. So we are going to have to use our slope formula to find out whether they're perpendicular or not. So I do that for the first line. So 4 minus 0 over -5 minus -3. That turns into a -2 slope. If you find the slope of the second line, you get -2 minus -3 over -2 minus -4, which turns into +1/2. They are opposite reciprocal slopes, so they do create perpendicular lines. And lastly, we'll write an equation. So we're going to write an equation that is perpendicular to -3x plus 1, and it must go through -6 minus 3 as the point. So first thing to choose or to figure out is our opposite reciprocal slope. So opposite reciprocal to -3 would be +1/3. Then we're going to plug that into our point slope form with the point that they give us. Both these minus negatives turn into plus positives. So there's our equation. We're going to distribute. Again, I did that 1/3 times 6 over here, but it does result in a 2. And then we're going to subtract 3 from both sides, and we get y equals 1/3 x minus 1 as our perpendicular line to that equation.